Hi guys, here is MIH. Apologies for not uploading videos for a while. I'm not in any trouble, just that I've been doing a bunch of projects, but none of them is really in depth, and they didn't produce satisfactory results. In this lab notes video, I'll try to document some scrappy things that I did, which was replenishing my supply of the three acids, namely sulfuric acid, hydrochloric acid, and nitric acid. First, sulfuric acid. I've secured a rather reliable and cheap source of sulfuric acid as lead-acid battery refill electrolytes. They contain minimal impurities as the battery won't work if the acid is contaminated. The acid was sold as 1.28 battery electrolyte, and its name indicates that its density is 1.28 grams per mil, or roughly 37% acid by mass. I was able to get 3,200 grams of this 37% acid, or 1,200 grams of pure sulfuric acid for 14 RMB or under $2, which is really just insanely cheap. The only drawback of this source is that the acid is rather dilute and I have to concentrate it by myself. After some experiences with different concentrations of acid, I concluded that having three distinct concentrations in stock, namely 37, 85, and 98%, is really helpful and convenient. I prepare the 85% acid by evaporating the 37 one in a beaker with a hot plate stirrer until fumes begin to dissolve or until the volume stops decreasing. As my hot plate can only heat a full beaker of liquid to around 250 C with a lot of heat insulation material, I cannot directly concentrate my acid to 98%. Besides, when the acid concentration goes past 80%, it starts releasing copious amounts of acid fumes, which are very irritating and corrosive. This 85% sulfuric acid is handy for applications such as making nitric acid and hydrochloric acid, which I'll show in a moment. I store most of my sulfuric acid in this concentration, as it is not that corrosive nor hygroscopic and can last decently long in storage, and acid solutions of varied concentrations can be easily prepared by it. For specialized use requiring concentrated 98% sulfuric acid, such as certain organic reactions, I distill my 85% sulfuric acid using an electric furnace instead of a hot plate. A furnace with exposed heating elements like this is handy, as it has the sufficient power to boil the acid reasonably quickly, usually within 5 minutes. The water and acid vapor released from the boiling acid is then condensed in the straight condenser filled with room temperature water. My condenser seemed intact even if I used room temperature water, but if you want to eliminate the risk of cracking the condenser, use warm or heated water. I don't recommend a forced air cooling, as I found that the cooling efficiency wasn't high, especially if you have a decent amount of water to boil off, such as my 85% acid. While the distillation is going, the distillate is routinely tested by soaking a small piece of tissue paper with a drop of distillate. If the paper chars after a few seconds and the acid burns a hole through it, then the acid coming over is decently concentrated, and the distillation is stopped. I don't need to distill all of the acid over, as I knew that they are pure 98% acid, so I can just let everything cool and store the acid. The concentration of 98% can be confirmed by measuring its density and read its concentration against the concentration vs density chart. This technique works for all acids, but especially well for nitric and sulfuric acid, as their density increases significantly as concentration increases. Just be aware that the measuring cylinder may be inaccurate and temperature would affect the density as well. Now I have stocks of sulfuric acid ready, I need to replenish my hydrochloric acid and nitric acid supply as well. Since I unfortunately cannot buy concentrated hydrochloric acid directly, I have to make it myself, but considering how cheap are the sulfuric acid and sodium chloride starting material, making it myself is still economical. Another good thing about this process is that the sulfate byproduct can be recovered and used as desiccants in organic chemistry experiments. After experimenting with sodium, potassium, and ammonium chloride and different concentrations of acid, I found that the best way was to directly distill a mixture of 1 mole of 37% sulfuric acid and 2 moles of granular or powdered sodium chloride, not to dryness, but until around 40 ml of slurry remains. There are 3 benefits of this method. It doesn't release a lot of hydrogen chloride vapor unless you boil it. All of the solid salts will dissolve at boiling temperature and ensure complete reaction even with a stoichiometric quantity of acid, and no annoying cleaning of solidified chunks of salt is needed as long as you don't boil to dryness. The slurry containing sodium sulfate can be directly poured out of the flask when it cools down, and the anhydrous sodium sulfate can be easily recovered by filtration, eliminating lengthy crystallization and drying steps to make anhydrous sodium sulfate. In this way, I was able to routinely produce around 200 grams of hydrochloric acid, typically 28% by mass, representing an 80% to 85% yield. If concentrated 38% acid is desired, hydrogen chloride gas generated by dripping 85% sulfuric acid on solid sodium chloride can be bubbled into the 28% acid. Finally, coming to our nitric acid. Again, directly stating the best way I found after a few experiments. Distill a mixture of 1 mole of 85% sulfuric acid with 1 mole of potassium nitrate powder. By using a 1:1 molar ratio instead of the 1:2 suggested by stoichiometry, troublesome chunks of salt residue can be avoided, as the slurry after the reaction can be directly poured out, and the potassium sulfate recycled if desired. Another advantage is that 98% sulfuric acid is not required unless you need anhydrous nitric acid. Alternatively, if you don't mind cleaning up the salt residue, then you can add another mole of potassium nitrate to the slurry and continue to distill out nitric acid. Although the yields will be lower than the first method with sulfuric acid in excess, typically 60% vs 95%, the concentration will be higher, 98% vs 80%, both of which determined by the density and mass of the acid. Of course, the numbers given here are only typical values, and your yield and concentration may be quite different. But still, a concentration of 75 to 80% is perfectly fine for most uses. A slight drawback of this method is that the nitric acid retains a light yellow color, and the color doesn't fade when the acid was heated lightly, but this doesn't have significant impact on the acid's reactivity. So yeah, that was how I stock up standard concentrations of sulfuric, hydrochloric, and nitric acid in my laboratory. I'll probably get on with some cooler and harder projects in the next videos, so stay tuned for that. See you soon!